Okay, what about now? Do you hear me?
Yeah, we can hear you now.
Is it okay? Okay.
Yes.
Okay, so let's just start the lecture. This audio, my computer audio is a problem. Anyway, let's just start today's lecture. I think today is the due date for homework. We finished nodal mesh. Do you have any last minute question about nodal mesh before I start new chapter?
Yeah, how do we decide the supernode from the
You have to bypass. That determines it depends on which element you want to bypass.
so we'll always bypass an element with doing the supernode?
So what's the point of supernode? I mean, when did we use supernode for nodal?
I guess it is the bypass, right?
Bypass what?
To find the unknown.
The voltage.
It's to bypass an element that is
Which element?
either passive or not, that it's blocking us from making other equations.
Why do we need to bypass a passive element?
Because it's
Let me,
restricting
okay,
us.
let me, wait. I'm going to call class several times because this is a class that I have to, I probably, let's consider the, please try to see the tutor. Tutor told me that nobody is showing up. I don't know, the timing, whatever. Because many students, not many, but there are some students that they are still struggling with the basic concepts. And I have to cover course material. I can just go over several times, but more than that, we really need to talk to tutor and maybe ask question by email or something. Let me go over class, see how many people even start listening to the lecture from the beginning. Aguilar, are you here?
Yeah, I'm here.
Okay, let me ask you. We finished nodal. The concept of supernode, this person wanted to know what is supernode?
I don't know, Professor.
Did I cover supernode?
Yeah.
How many times?
In this chapter and a different chapter.
Why? Not understanding supernode. Why not knowing what is supernode now? What's so difficult about supernode? I'm trying to, because I'm trying, I don't know how to explain it because I reached a point that I have to ask help from the students to see how to cover it. I don't know.
Professor?
If anybody,
it's arbitrary.
Okay, let's do it this way. If anybody in this class listening right now knows a better way to cover supernode, please speak up, open your mic and explain to the rest.
Supernode
I think
is...
this. Sorry, go on.
Oh, pardon me. Imaginary node that we create a loop with to enclose a path with an active element, active source.
It doesn't have to be active element in general. Anytime you want to bypass portion of a circuit, you use supernode. You just draw this closed path and pretend that you don't see the inside. That's a supernode. Okay, that's a general definition. When it comes to nodal, Alejandro, are you here?
Yes.
For this circuit, which part is qualified for supernode and why?
Would be the 4 on the left-hand side, 4, 2, and 4.
Why? Why do you think 2 and 4? Why? I mean, if you want to answer the question, give me the reason for it. Justify your question, justify your answer. This is nodal. Have you studied nodal? Let me ask you, have you studied nodal?
Yes.
Yes.
No. I'm asking, going one person by person. Alejandro, because this is the only way you don't see each other. So you don't do it. I'm just, in class, I just ask you to raise your hand. But here, I have to go by name. And I have to involve. Otherwise, it's a pointless lecture, anything. Because regardless of what I'm saying, apparently people are not following up what I'm saying. So what I'm explaining. Alejandro, have you studied nodal?
Yes.
Okay. What do I do in nodal? This is a circuit. Give me nodal equation. How do you write nodal equation? Let me put 10 volt here.
Would be 4.
What do I do in
equals
nodal? 4 equals to what? I mean,
4ix plus 10.
what are you talking about?
Ix.
Is this nodal? What you're talking about? I'm talking about nodal method. What's the preparation for nodal?
The ground.
Amador, are you here?
Yes.
Okay, what's the preparation for nodal? I'm going to explain just one more time. And from now on, I explain each topic. It's going a bit too far with this class. I don't know. I haven't had this situation with circuit class. I'm teaching this class for the past 20 years. I'm telling you, like, since I came to Cal State, I'm teaching circuit. This semester, it's unbelievable. I don't know what to do. Really, I reached a point that I don't know. If anybody can help me and tell me and guide me how to do it, I'll do it. I spent entire lecture on nodal, step by step. I put guideline, cookbook guideline. One complete example, 2 complete examples in my handout that went through step by step. I did 2 problems on the board here in class. I slowly kept it for the entire lecture. This class, you cannot say I erased it fast. I kept it on the lecture. I went around class, called name, one by one, and tried to involve. And I still reach a point that people don't know what is supernode, what is nodal analysis. Nodal is the main part of circuit. Please go and take this class with any university and see how they teach that. They don't even stop at one method for 2 lectures. One method they don't even either cover, or they say they just put 2 examples and ask a student just go practice on example. That's it. I don't know. I really don't know. I'm sorry. This class is something that I really, the reason I get passionate, because I don't know what to do. Sometimes I find a way to go around it or do something about, but for this class, I really, really don't know how to do it. So what I'm going to do right now from this class on, I put a responsibility 90% on your shoulder now, because it's going a bit too far. You have to study. You have to do the problem. I cover once, I go through 1 or 2 examples, and that's it. That's it. You're on your own. Study homework, do whatever you can do it. I mean, how many times should I explain nodal analysis? You choose a reference. You choose essential node. You choose 2 essential nodes here. You assign current to the passive element. Isn't it familiar? And then you write KCL. How should I say that to make it more sense? KCL here, current is given voltage source current you cannot assign. So you bypass. And then somebody asked me, oh, we bypass passive element. Why should I bypass passive element? You bypass the element that you cannot assign current. How should I say that? And then you look at this node, 1, 2, 3, 4 currents connected, you write KCL. How can I make it easier than this? How? If somebody has a better way to do it, let me know. If you can find somebody, faculty, person, anybody, they can do it better than this, let me know. I'll invite the person to do that for you. I mean, if you give me a circuit and ask me to show nodal on it, I can understand. But if somebody asks me right now that what is supernode? And then I ask, okay, supernode is to bypass. Which element should I bypass for nodal? And then people say 6 ohm or 4 ohm, or somebody says, oh, the nodal equation is 4 equal to what? Are you writing KVL equation? What's going on? Can somebody open the mic and help me? What's going on with you guys and circuit analysis? What do you want me to do? If I put 10 examples, it confuses you more, I think.
I think that's actually better. More examples.
No, it is not. For nodal, I did 3 examples in class, and I did 1 completed example. And then when I ask about supernode, this is the example I have. You're talking about 10 examples? Okay, first of all, if I do 10 examples per topic, how do I finish the assigned topics? I still have a long list of topics to cover for this class. It's not my choice. It's a university board of engineering, ABET board. We have to cover certain topics. Otherwise, you're not qualified to pass circuit 1. You have to take upper division courses, and they hold me responsible. You have to take EIT exam. I'll be responsible. If I give you 10 examples per topic, how should I cover all the way up to AC? Don't you think that I can give you 1 or 2 topics and the rest you should find it on your own? There are plenty of examples if you go online. You have a textbook. You choose not to buy a textbook. That's your choice. And then I did this example I did in class. This is the example I did in class. Didn't I say that take the example I do in class, or it's in the handout. This is also in the handout. Repeat it 10 times instead of 10 problems. If you repeat this problem 10 times, then when I ask you, what is nodal in this case? I didn't continue the classes. Probably more than half a class will be quiet.
Can we go over 3.99 in the homework?
I think
I just do 1 problem and then I'll continue with my lecture. Okay. This is writing nodal and mesh. Now it's a good example. I go around class and I ask you 5 times, 10 times, until one person gives me the correct answer. Because anything I covered in my lecture, anything with my example, that 1 example I showed you, that covers everything about this problem. Everything about this problem. This 1 problem should be a full practice on nodal and mesh. You know, in circuit analysis is 1 topic that when you ask most professors in electrical engineering, they don't want to teach, because it's a very frustrating course for people to teach, because people do not. Let me just put, these are ohm. They put kilo ohm. We just put instead of kilo, because my focus 2, I just put 2 amp. Because for this problem, they just ask you to set up the equation. 2 amp. Okay, let's just start with nodal. Let's continue with the class list. So far, no luck. Hopefully, Argondona. Are you here? You have to participate.
Yes, I'm here.
Okay, for nodal, what should I do? Give me the preparation for nodal.
We find a reference node.
Okay, what reference you choose? That's totally up to you. Choose any reference. You can choose the bottom line, the top line, any point, whatever comes to you as a natural choice.
The bottom.
The bottom line, okay. So this is a reference. Let's go to Beltran. What is the other preparation? Beltran?
Yes, I'm here.
Okay, what is the second preparation? We have a reference.
Use KVL. Oh, sorry. You said other reference?
I chose a reference. What's the step 2?
Yeah, use KVL.
What KVL? Nodal is KVL? Have you studied nodal? How many guidelines nodal has? How many steps before you write the equation? Nodal is based on what equation?
Sorry, it's a KCL, not KVL.
But before writing KCL, I have to do some preparation. What is the next step after choosing reference? Bernal.
The next step would be to specify the essential nodes.
Okay, give me essential node, except for
So-
reference.
So there's the 2 resistor 8 and the 1.
Okay, is this essential node?
Yes, because there's 3 things
Okay,
to it.
maybe my solution, when I send you solution, my solution, I don't have solution in front of me. So maybe my solution labeling is different. It doesn't matter. It's just a label. Is this essential?
Yes, it's all that horizontal line right there.
Okay, good. 3, 4. There is one more essential. Where is it?
At the top.
The top.
Top left corner.
Top, the whole thing. It's a straight line. So we have 5 essential nodes. We have 5 essential nodes. So for each node, we assign a voltage. V1, V2, V3, V4, V5. You don't have to show it here, provided that it's plus at the node minus at reference. Plus at the node minus at the reference. Okay, Abdul Castaneda. Abdul Castaneda,
Yeah.
what is the next step? We have essential node, we have a specified essential node, we have,
Do we assign current already or?
no, not yet, current direction. So we have to assign current direction, any direction. Again, it doesn't matter. Let me just put the direction just to make the process faster. It doesn't matter. You can make it to the left, to the right, up, down. There is no passive sign checking here. Only passive elements. How many passive elements here? We have 1, 2, 3, 4, 5. Those of you still struggle with passive element resistor is passive element absorbing energy. This is the 20th times defining passive elements. The rest of them, they are active elements. So only passive elements you assign current. Castro, Ivan Castro.
Okay, I'm here.
Okay, so what type of equation? Somebody said KVL, is that correct?
No, it's KCL.
Okay, KCL. Okay, let's start with KCL 1. Is it feasible for KCL or not?
Yeah,
Okay, give me KCL.
it would be V1 minus V2 over 1.
Leaving, right?
Yeah,
And then,
you said and then?
okay, V1 minus V2 divided by 1. I'm writing equation. Okay, then what?
And
Give me
then
equation,
plus 6.
something. Sorry?
Then
Equation
then
means something plus
minus
some
2A.
2A. Which side goes 2A? How many
Same
currents
side,
enter?
minus 2A.
Is it the same side? Oh, okay, minus 2A. So two currents entering, 1 current leaving. This is leaving current equal to the 2 currents entering, 2 amp entering. What else is entering?
Let's see. I guess.
Why it's okay? Let me ask.
V3
Why it's so?
minus V-
Is it V5 minus V1 over 2?
Okay, what is so difficult to see this? Somebody please explain so I can explain 100 times. Why is so difficult to see this? The current goes from 5 to 1, it's entering. Isn't it V5? Isn't it V5 minus
No, I see
V1
it.
divided by 2? How many times? Somebody said 10 problems. If I do 10 problems, it's the same situation. People keep it quiet. They don't say anything. What should I do?
It's just a lot to keep track of for me. But I could have done
No,
it like if I was on my
actually,
own.
actually, this is not a lot because I'm not talking
Actually,
about
I
this.
think
Sorry,
it is.
don't
Because
take
it
me
is
wrong.
mine, like,
Because this
like-
is a current moving. I just asked to write the current. Current is moving from node 5 toward node 1.
yeah.
So it's V5 minus V1 divided by 2. I'm entering the node. So it
Yeah.
goes, I'm 2 amp entering. Okay, this one we've kind of, explained a lot. Let me jump to node number 4. Claire, because this is repeating the same thing for node number 4. What's the situation at node number 4?
We have 2 amps entering. We have V4 minus V3 entering. And V4 over 2 leaving. So
You said
equals-
V4 minus V3 divided by, don't forget. And then you
Oh,
said,
yes.
yeah.
Yes, I'm sorry.
And then you said, what is
Equals,
leaving?
leaving is the V4 minus 0 over 2.
Okay, is this correct?
No,
What is the correction here?
it's V3 minus V4.
Oh, yes.
So this is equation 2. Remember, in this problem, they didn't ask you to solve, just set up the equation. So you just equation 1, equation at node number 4. This is node number 1, this is node number 4. Okay, let's go to node 5. Let's go to node 5. Okay, what's the problem with node 5? I mean, what's the KCL node 5? Let's go to Contreras. Let's go, this is node 5. Contreras, are you here?
Yes, I am.
Okay, how many branches connected to node 5?
We got 4.
How many currents entering, how many leaving?
Got 3 leaving.
And then what about this branch?
Enter.
Did I assign any current to this branch?
No,
So what's this problem now?
that we don't have a current to assign to that voltage source.
Okay, then this voltage source is causing problem. If it's causing problem, I have to bypass. What do you suggest? How do I bypass?
You create a supernode.
Okay, can you, even though it's not face-to-face, can you describe to draw a supernode? How should I draw that supernode to bypass this voltage source? I have this problem. This is the only tricky part. I want to bypass. Bypass means anything connected to the voltage source. So I should bypass this node. But this node is not just one point, it's the whole thing. So it's the whole thing because I have to bypass. Because this node is the whole node. Then I have to also bypass this node. This is my supernode. I bypass this end of the voltage source. See, the voltage source should be completely inside your bypass loop. So this node of the voltage source is actually the entire line. So the whole line should be inside your supernode. This node should be also inside your bypass loop. So this is the way I bypass my voltage source. Okay, Delhi, are you here? Okay, look at this path, kind of brownish color path. Why you're not seeing it? Okay, it's okay, it's okay. It's okay, it's okay. I go to the next person, Estrada. No, I don't want to cause any problem. Estrada.
I'm here.
Okay, do you see this big node?
Yeah, I see.
How many lines connected to this big node?
3.
Garcia, Sandoval. How many lines connected to this big node?
6.
1, 2, 3, 4, 5, 6. That's visual, that's not math, that's not circuit. I'm just drawing a path and ask you how many external line connected? 1, 2, 3, 4, 5, 6. Any objection?
No.
Okay. Jose Garcia, out of these 6 lines, how many currents entering, how many leaving?
For what exactly?
For this big node, somebody said 6 lines. 1, 2, 3, 4, 5, 6. How many currents entering this big node? How many leaving?
Say 3?
3 what? Entering and 3 leaving?
3 leaving and 1 entering.
We said we have 6 branches, so we must have 6 currents, 6 different currents. 1, 2, 3, 4, 5, 6. We have 6 branches connected to the node. How many entering, how many leaving?
1, 2, 3.
Okay, let me ask the entire class. What is so difficult about the visual part of circuit? I'm not talking about Ohm's law, KVL, KCL. You have a closed path, you have lines connected, and the arrow direction shows the direction of the current. Why it's difficult to determine how many currents entering, leaving? Isn't it obvious? Leaving, 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 entering, leaving, entering. We have 2 entering, 1, 2, 3, 4 leaving. What part of that is complicated?
So the 3 to the left are entering, and the very bottom one is entering.
Entering where? Entering nodes?
You just told us.
Based on what you're saying, 3 to the left are entering. Why they are entering? What is the direction of arrow, leaving or entering?
Okay, never mind. I see it. What about for V2? Is that one entering or leaving?
Which one?
The current for V2. Is that entering or leaving?
This is leaving.
Entering.
Entering. I mean, what is the direction? Okay. Is this current leaving or entering? Let me go one by one.
Leaving.
Is this current entering or leaving?
Leaving.
Is this one entering or leaving?
Entering.
Is this one entering or leaving?
Entering.
Leaving?
Entering.
Is this one entering or leaving?
Leaving.
This one?
Leaving.
So 4 leaving, 2 entering. Okay, give me the list of leaving currents. Let me go to Gonzalez, Sebastian Gonzalez. Give me the formula for all the leaving currents.
Is it V5 minus V1 over 2?
Okay.
And then for the second one, would it be V1 minus V2 over 1 or plus?
No, this node.
Oh.
I'm talking about in this node. I just said this is leaving, 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 leaving. Just give me the list of leaving current.
Would the next one be V5 minus V2 over 4?
Mm-hmm.
It should just be 4 milliamps.
Yeah, that one's just 4.
Oh.
Then plus 2 amps. And then there's V3 minus V4 all over 1.
Okay, entering. You have 2 entering, 1.
V2 minus V3 over 1. and then 4/2.
That's equation for node 5. Any question? Any question? And I'm pausing long enough to see if you have any questions.
Yeah, I have a quick question. I'm
Yeah.
still having a hard time understanding. Like, I understand the whole leaving and entering thing, but when it comes to like the V5 minus V1 over 2, I get that part, but I don't understand how it's V5 minus V1 and so on and so
What's
forth.
the voltage at this end? What's the voltage at this end?
It's V5. So is
What's the
it
voltage at this end? It's a
V1?
I did.
So
Okay, it's a voltage
from-
difference from according to passive sign. It's a voltage difference going according to the direction. Direction goes from 5 to 1. If V5 minus V1 divided, it's volt divided by ohm is amp.
Okay, yeah. All right. That's what I needed to understand.
Okay.
It's just for the direction.
Yeah,
Whatever
yeah.
the direction
The
is going.
direction determines, yeah.
All right, cool. Thank you.
Any other question?
How is V3 minus V4 over 1 leaving?
This is the current leaving, right? Is it leaving or entering? The current here.
According to the arrow, it's leaving.
Okay, leaving from where to where?
From V3 minus V4.
Divided by 1 ohm.
Okay, got it. Thank you.
Any other?
Yeah, Professor.
Mm-hmm.
You might stop me, but for voltage at node 2, is there since we don't know the current at that independent voltage source, how do we express that? Because now it's connected to ground, so we can't say V2 minus 0 equals 6.
I didn't write any KCL here yet. Are you talking about this KCL? I'm writing.
Sorry,
node.
no, I'm talking about the one you haven't done yet. Just because there's gonna be another.
Okay, yeah, I'll do that
independent
later.
source.
That's my. At first, I'm checking to see if they have any question about this one. First, I'm checking to see if anybody has any question here. So we finished node 1. We finished node 4. For this node, I use supernode to bypass. We have one more node left, the one that you just mentioned, this one. Okay, let me go to Haro.
Actually, I had a question.
Yeah.
This is like an essential question, I guess. It's just because that has a source, like we have to bypass that.
Yeah, because the nodal says do not assign current to the voltage source. Current is not 0, but it's undetermined. So if your KCL is based on current, if I don't assign current, how do I write equation? Since this voltage source, there is no current associated, I have to bypass it.
So, but you have to do that since it's a active or not an active, but an independent source, right?
Dependent or independent. It's a voltage source and you don't assign current to voltage source in nodal.
Okay. Well, okay.
Okay, let's go
what about the 6 ohms down here, like where your pen is right now?
6 ohm, 6 volt.
Oh, 6 volts. Yeah, sorry.
That's the next step. Haro, Mr. Haro, are you here?
Yeah. So the equation
Okay, let's
going
go
into that.
Okay, for node number 2, how many branches connected to node number 2? So we are going now to node number 2. 1, 2, 3, 4. Okay, do you see current directions for number 2?
Yeah. There's 3 specified current directions.
But 6 ohm is undetermined, right?
Yeah, that one's unknown, but there is a current there.
There is a current, but we don't assign. So you have a
it's
problem
unknown.
with because we have a problem with KCL. So you have to bypass 6 volt. Can you again describe by words how to bypass 2? Remember, anytime you bypass, You have to bypass anything connected to that 6.
By you have a super node covering the reference node all the way up to V2.
I mean, you're bypassing.
Bypassing, yeah. A super node. Yeah.
Actually, in this case, your voltage source, this is the problem. As I said, this problem is kind of for circuit 1, it's kind of a little bit advanced problem. Actually, in this case, first, before you write any equation, any more KCL, this one we finished, this one we finished, this one we finished. How many nodal voltages we have? We have V1, V2, V3, V4, V5, right? According to nodal, you need 5 equations. Okay, according to nodal, you need 5 equations. If you generate 5 equations, you're done. We have equation 1, equation 2, equation 3. So far I have 3 equations. Any problem with that? I need 2 more equations. Need 2 more. So before we think about KCL, don't think about KCL. Go and use your voltage sources. How?
You can say that 6 volts is equal to the voltage distance V2 minus 0.
So V2 is actually given. V2 is equal to 6 volts. Mr. Hermosillo? Yep. Okay, go to 4-volt voltage source. How do you connect 4-volt to the voltages at 2 terminals? 4 volts. 4 volts is connecting node 3, this is node 3 and node 5. How node 3, node 5, and 4 volts are related?
Using the reference node.
Aiden Lee.
Here.
How do you use 4 volt? How do you use this voltage source to get information?
KVL?
Leon.
Yes.
We never use KVL in nodal. Why you keep saying KVL? KVL, when did I use KVL for nodal? If I want to use KVL, why should I use shortcut nodal? I go back to general method. Why do I need KVL? I have a voltage source connecting node 3 and node 5. And the voltage is across, between. What is the voltage in between 2 terminals? Please, I don't know, repeat it to yourself. It's a voltage between 2 terminals. Right? So, Leon, what is the voltage association to 4 volts?
It's V5 minus V3 equal 4.
Exactly. It's a voltage at this end. V3 at the plus side minus the voltage at the minus side. V5 equal to 4 volts. And it's not ohm or anything. It's equal to 4 volts. Okay, how many equations we have now? 1, 2, 3, 4, 5. No need for any more KCL. No need to bypass or anything. If you bypass, you're just doing extra work. No use. Once you write some equations for large circuits, always go back and recount to see how many equations, and use voltage. Maybe from the beginning, use voltage sources. So that way you have a better idea. From the beginning, write V3 minus V5 equal to 4, put it aside. V2 equal to 6, put it aside. So you need only 3 more equations. Equation 1, equation 2, and equation for supernode. So you have a set of 4 equations for unknowns. And these are all algebraic simple equations. You can solve them. But the problem, in the exam, I'm not going to ask you to solve 4 equations for unknown.
Professor?
Yeah.
I think you wrote V5 minus V3, not V3 minus V5.
Oh, sorry. Thank you. Good. At least we have some people, they detect that it's. Thank you.
I have a question with about the equations, the
Yeah.
5 equations. If you were to set it, all these three, oh, I'm sorry. If you were to set up these equations into a 5 by 5, would you be able to do that without having to
Yes.
solve it algebraically?
First of all, V2 equal to 6. So plug in V2 equal to 6. Don't keep any constant, because that you actually have 4 equations for unknowns. You actually have 4 equations for unknown. If you want to use Kramer, for example, if they ask you to solve, you want to format into 4 equations for unknown, I have to erase something here. First of all, you have to write them in systematic format, in mathematically nice format, clean format. Clean format means from used order. Like, for example, in this case, multiply first of all by 2. So you get 2v1, and then 1v1 goes to the other. So this equation is simplified as 3v1, and then minus v2, minus 2v2. Okay, there is no v3, v4. Take v5 to the other side. So you have minus v5 equal to, you get 4. This is actually equation 1. For equation, go to node number 4, write your equation 2. In this case, you have v3. Again, you multiply by 2. So you have 2v3 minus 3v4, taking v4 to the other side, minus 3v4, equal to minus 4. This is your equation 2. If you want to simplify. Because sometimes when you take EIT exam and they give you nodal equation, it's in this form, not in fractional form. So you have to simplify. I mean, clean up. This is called the cleanup process. Then you clean up this equation and write them in systematic order. So let me first get rid of, okay, you have 2. Let's check. And taking, maybe we take voltages to the other side. So V1 goes to the other side. So I get V1. I just do it by quick observation. Please double check yourself to make sure that I'm doing it correctly. Then you have 2 minus, write them in order, minus minus 2v3 minus, yeah, multiplying by 2 minus 3v3, because there is v3 also on this side. And then v4, taking to the other side, plus 2v4, double check yourself, 2v4, the cleanup process, taking to the other side becomes plus, and then minus v5, minus v5. Oh, wait a minute here. I'm going to use v2 first before. Okay, so I have also v2. I'm taking everything to the other side. I also have v2 here, v2, and then v1 to the other side, v1. v1 plus v2 plus 2v2. Because you can do it in several steps. I'm trying to save time. 2v2. v1, 2v2, 2 and 1 is 3v3, and v4 is 2v4 minus v5 equal to equations we have 4 plus 2 is 4 plus 2 is 8, 6, it's 12, because you multiplied both sides by 2 by the denominator, minus 8, because 4 is also multiplied by 2, taking constant to the other side. 12 minus 8 is 4. Again, double check, please. So this is equation number 3. Then put the other 2 equations you obtained by voltages, V3 minus V5 equal to 4, and V2 equal to 6. Okay, now go back and substitute. I can erase my circuit now because I'm doing the math part now. I can erase the circuit. This is homework problem, so you will see solution anyway. As I said, my number for the solution may be different. I don't have my solution in front of me. Okay, so now you make it like 4 equation, because V2 is equal to 6. So minus 2 times 6 is minus 12. Minus 12 taken to the other side, you have 3v1 minus v5 equal to 6 times 2 is 12 plus 16. And then you have 2v3 minus 3v4 equal to minus 4. Then you have v1. 2 times 6 is 12. 12, 2 times 6 is 12. 12 taking to the other side, minus 8. So it's minus 3v3 plus 2v4 minus v5 equal to minus 8. And then you have v3 minus v5 equal to 4. You have two options to solve this problem. For example, in this case, find v5 from here in terms of v1, and find v5, maybe eliminate v5 and v3. v3 in terms of v5, v5 in terms of v1. So you find v3 and v5 from these two simple equations in terms of v1, plug it into these two equations. You get only two equations in terms of v1 and v4. Two equations to unknown. That's math part. If you want to write your delta, by the way, I give you delta setup, maybe not finding determinant. With calculator, you can find determinant, but setup, I can give you this equation and ask you just to set up your delta if you're using Kramer's method. Okay, what is the first row? 3, there is no v2, there is no v3, there is no v4 and v5. Then there is no v1 for equation number 2, there is no v2, v3, v4, no v5. Row number 3, v1, there is no v2, minus 3, v4. Actually, what I'm going to do is, sorry, I don't want to, but why do I need to use 0, 0 row? You can eliminate v2. v2 is not the unknown. So you set up your Kramer's rule according to the following: v1, v3, v4, v5. You make it like 4 by 4, not 5 by 5. There is no v2 here. v2 is a constant. So you do it according to this format. So it's 3, equation 1, there is no v2, there is no v4, and minus 1. So you reduce the size because one of them is constant. Then you go to equation number 2. There is no v1, v3 is 2, v4 is minus 3, and there is no v5. Equation 3, v1, minus 3v3, 2v4, and minus 1v5. There is no v1, v3 is 1, there is no v4, minus 1. It's a determinant of 4 by 4. You can use your calculator, but again, in the exam, I'm not going to ask you to find determinants. Then I have to erase. Then you have to define, because you have 4 unknowns, v1, v3, v4, v5. Then you have to define delta and use the same subscript as the voltage, like delta 1 for v1. Delta 1 is the same 4 by 4 matrix except column 1. So you repeat column 2, 3, and 4. So you repeat 0, 0, minus 1, 2, minus 3, 0, minus 3, 2, minus 1, 1, 0, minus 1. Column 1, under V1, you substitute by the right-hand side. 16, minus 4, minus 8, and 4. This is your delta 1. Then you write your delta 2. If you want to use Kramer's method, any n by n matrix, we use Kramer's method because determinant, now you can find it many simple math programs, including some calculators. They can go up to, I guess, even 8 by 8 matrix to find determinant. Okay, for delta 3, I'm going to use the same subscript as my voltage, delta 3. Go under V3. Do not write that one, but the rest is the same. So 3, 0, 1, 0 is the same. Then 0, minus 3, 2, 0 is the same. Minus 1, 0, minus 1, minus 1 is the same. But column under V3 is the right-hand side. So it's 16, minus 4, minus 8, and 4. And you find the determinant. Do the same thing for delta 4 underneath column 4. You repeat delta underneath column 4, you write the right-hand side. Underneath column 5, we write the right-hand side. So in this case, V1 is equal to delta 1 divided by delta. V2, we already know it's a voltage source. We already had 6 volts. V3 is equal to delta 3 divided by delta. V4 is delta 4 divided by delta. V5 is equal to delta 5 divided by delta. You have all 5 voltages, nodal voltages. Now, if you go back to that equation, to that circuit, original circuit, ask any question about that circuit, any question. It's related to these 5 voltages. There is no way that you can find any question that you cannot relate to V1, V2, V3, V4, V5. That's the strength of the nodal. Any question about Kramer's setup? I think somebody had a question about Kramer's setup. Okay, let's do the setup for mesh. Let's do the setup for mesh. Okay. I have to draw the original circuit again. Mesh is a little bit cleaner in terms of assigning. I'll put my circuit here. Again, in the circuit that you have kilo and milli, I just, because I want to focus on method, okay. Okay, for mesh, now write mesh equations. You either have to write nodal equation or mesh equation to solve the problem. Let's go to Macias. Are you here?
Yeah.
Okay, what's the preparation for mesh?
You specify all simple loops.
Okay, how many simple loops do you have in this case?
6.
6 simple loops. So because in order to read the problem, let me check to see if I have, I don't want you to get confused when you read my solution, because this is going to be the same as solution. I'm going to use clockwise direction for all of them. Doesn't matter. You can use clockwise, counterclockwise, anything. And I'm going to use the same order. So we have 6 loops, and we're going to assign I1, I2, I3, I4, I5, I6. Okay, let's go to Melendez.
Yes.
Okay, now for loop method, we assign loop currents. What's the next thing? What's the next step? What's the next preparation?
We want to assign voltage polarities for all passive elements.
Yes. Okay, for voltage polarities, I'm going to assign again because I want to, when you read the problem for nodal, I didn't have solution in front of me. So I'm going to put, it doesn't matter. You can choose, please, please, please remember. By the way, this is 1 kilo ohm. I mean, these are all 1, 1, 1, and 1. It's a problem from textbook, so I have to choose the number. So I'm going to use polarities, any polarity. Let's say plus or minus, plus or minus, plus or minus. We only have, let's see, 1, 2, 3, 4 passive elements. Okay, Mendiola.
Sorry, Professor, there's one more resistor on the end.
Oh, okay, thank you. Let me see, thank you. Plus minus. Yeah, 1, 2, 3, 4, 5 passive elements. Mendiola?
Yeah.
Okay, what's next?
Equations.
How many equations? How many equations do we need? First, you have to check that.
Professor, real quick, you're not gonna label your passive
Voltages,
elements?
no. No, we don't
No?
label voltages, no. We just label
Okay.
currents.
Okay.
We only label.
We don't need to do like R1, R2, R3, R4?
No, because numbers are given 2 ohm, 1
Oh,
ohm,
okay,
1
same
ohm, 1
thing.
ohm. Yeah,
Yeah, same
yeah,
thing.
yeah.
Okay.
Yeah, yeah. You can label them, but you know, you mess up your, I mean, you make it your work a bit longer. You don't have to. You just directly use the number. Okay, how many equations? Who I was talking to, Mediola. How many equations do I need? Number of equations, 6. So if you provide 6 equations, you have complete correct list of mesh equations. Okay, Monje, Paul.
Yeah. Yeah.
Okay, how do you write those? How do you start to get those equations? From where? From what?
From your little loops.
Oh, before using loops. Pedro
Oh, you can do
Munoz?
the current first, right? The
Oh,
current.
yeah, the current sources. Okay, because you said it.
Wait, what?
Okay, we got to use current sources. Alexis Moreno,
Yeah, here.
how many current sources?
There's 4.
So we can generate 4 equations. Let's just start with this current source. I'm pointing with my pen. How do you relate to mesh currents, this current source?
So you're right. I1 minus I2 is equal to 4 amps.
Correct. This is equation 1. Okay, let's go to Sarahi Yunus. What about this current source? What about this current source? Pointing with my pen.
That's 2 amps.
Equal to what?
It's equal to
What mesh current is passing through this?
I3.
Is it the same direction?
No.
I3.
Oh, yeah.
Yeah. This is equation 2. These are just Moreno. What about this current source?
That one's gonna be I4 equal to 2.
What about, let me go to Portillo. What about this current source?
Is that going to be their opposite direction? So
How
would
many?
it be? I'm sorry?
This current source is between loop 5 and loop 6. Okay, so what's the loop
Also,
current?
would it be I6 minus I5?
Yeah. Equal to what?
6.
What's the value of the current source? 4.
I mean, sorry, 4. I was looking at the other one. 4.
This is equation 4. Notice that out of 6 equations, we already have 4 very simple equations. So current source, maybe mesh current for this circuit is better than nodal in a way for this circuit because we have so many current sources that we can easily generate simple equations. Okay, Rivers.
Here.
We need 2 more equations. How do I get those 2 equations? And I ran out of current sources. I need 2 more. How do I get those?
Do we get them from the voltage sources?
Tell me. How?
Oh, so look at one of the loops with the voltage sources. So for example, the I3 one, and start writing the equations.
KVL equation, right?
Yeah.
So I need to write KVL equations. So just start with simple loop. Which simple loop is feasible for KVL? Is loop 1 okay for KVL?
No.
Loop 2?
No.
Loop 3?
Yes.
Okay, this is loop 3. Am I passing through a current source?
Oh yeah, you are.
So loop 3 is not feasible. Loop 4,
No.
5,
No.
6.
No.
So I have to use combined loop. I need to find two combined loops. Robles, can you give me, by identifying element, which combination is suitable for KVL? Give me any two combination, doesn't matter.
There's a voltage between I3 and I2, voltage between I5 and I1.
Okay,
Can we use Ohm's law?
Okay, let's keep 4 volt. If I keep 4 volt, 1 ohm, 1 ohm, 2 ohm, this loop is feasible for KVL because you have passive elements and a voltage source. This is one choice. Usually, remote is not, it's difficult to identify the path, so I'll do it. This is feasible for KVL. But let's go to Rosha.
Yeah, I'm here.
For this loop, give me KVL. Let's call it loop A, or loop A. This is equation number 5. Give me KVL equation for this loop. Now back to chapter 2, chapter 1, chapter 2 actually. It's a KVL. Write the KVL equation for this loop. Do you know how to write KVL?
Would it be I3 minus 2 is equal to
Do you
4?
do you see I3 here?
Oh, my bad. I was looking at the outside. Sorry. So, would it be...
If you turn on your music down, probably you can listen better because I hear the background music. If you lower your audio, the music audio, while I'm lecturing, maybe you can focus a little bit more on this one. Okay, let me go to Janet Rodriguez. At least when I call your name, you turn on your mic, try to turn on your audio. If you're listening to some music, background music, or watching TV. So that way, I feel at least for the time that I'm connected to you, you're focusing on my, lecture. I can't wait to go back to face because this is a problem. I don't know. Anyway, I don't want to get into this at this point. Okay, this is a KVL. Janet Rodriguez, are you here? Janet Rodriguez? Janet Rodriguez, you're not here. Okay, what's the date today? 10/12. Okay, Marlene Rodriguez.
I'm here.
Okay, give me KVL for this. Let's do it this way. For this KVL, how many voltage rise and drops do you see? Any direction you want to move, doesn't matter. Start from the source. Just keep moving in clockwise direction. Is it a rise or drop from voltage source?
They're both rises.
It's a rise, 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 rise. So you have rise all the way. So you have all terms on one side. Okay, give me the KVL voltage, KVL equations. They're all on one side.
Would it be I2 minus I5 times 1?
Okay.
Plus I1 minus I4 times 1. And then it's going to be I1 times 2. Equals 0.
What happens to the voltage source? Voltage source is also along the way.
Plus 4 equals 0.
Okay, Rojas, do you agree with this formula? Rojas, are you here?
Yeah, I'm here. Give me Yeah, everything is. Oh wait, no, it's I5 minus I2 over times 1. And I4 minus I1 times 1.
Okay, so let's do it. I4 minus I1 times 1. And this one, I5.
It's I5 minus I2 times 1.
Correct. Correct. What about this one?
Yeah, that's correct.
I'm writing this equation. I1 is I1 going through.
Oh, it's negative. It's
so it's 2 ohm times minus I1 because it goes against. So this is the correct equation. Okay. Good. Maria Rosales.
Yes, Professor.
I need equation 6. I'm going to highlight one. I need closed path without current source. I'm going to highlight this closed path here.
Through the 6-volt source.
Okay, you give me KVL. First of all, 6 volt is rising minus to plus. Plus, minus, plus, minus, plus, minus. So 3 drops, 1 rise. So you have 6 volts equal to. Okay, what about, give me the voltages here, the 3 drops.
I see I5 minus I2 times 1 ohm.
Correct.
I see plus I6 minus I3 times 1 ohm. I see plus, that's the 2 kilo ohm times I6.
Good. That's equation. You get all 6 equations unknowns. But notice that I3 is not equation, it's equal to 2 amp. You plug in. I4 is 2 amp, plug in. You actually get same as nodal, 4 equations, 4 unknown. But 2 equations are 2 simple equations and 2 are a little bit longer. Pretty much you get the same result as nodal. But observation is easier than nodal, but same as nodal. Okay, this is your mesh. Any question about mesh? Notice this is the third, actually 3.5, 4th lecture on nodal and mesh. Very short chapter where I don't want to, I don't know, say it again, but really the amount of time they use, ask any other student, the amount of time is spent on mesh, nodal, in many schools is just all of them with example, everything less than 1 lecture. Here, the reason, and again, as I said, I don't mind. I don't say it's study or not study. The problem here is you have to know these 2 methods very well, because these are 2 methods that if you feel comfortable, then you don't have any circuit analysis problem in future or in any situation. You can handle any circuit. That was my claim. But anyway, you have any question here? Let me continue.
Professor, I had a question.
Yeah, before doing that, because I have few people left, I don't have time to involve them in my question answer. Let me see what time is it. Actually, I hope I'm not going overtime. Yeah, I go overtime, so I'm not going to call. I mean, the rest of the class, that's okay. I don't put any absence. Class time is ended, and I'm not going to do any more mesh nodal. Next lecture is going to be application, one important application of nodal in electronics. That's operational amplifier. It takes only 1 lecture, that's it. But go ahead and ask questions. Yeah.
On the combined loop,
yeah.
Everything makes sense. You use KVL but I think for the voltage rise, you made that negative because of the current going on the opposite direction of the
current has nothing to do with the voltage source. Independent voltage source has nothing to do.
On the passive element, not the voltage source, on the passive
element.
I
see. For passive element, which are you talking about, this loop?
Yeah, that loop. In particular, when I1 crosses is that passive?
Okay, this is like a voltage rise, voltage. First of all, you have to determine about rise or drop. It's a rise, 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 rise. Then you use Ohm's law. Ohm's law is all passive sign. So you have 4 volts plus. What is the voltage? 1 ohm, but it has to follow passive sign. I5, passive sign, I2 opposite. So I5 minus I2 times 1. Then for this branch here, I4 is passive sign, I1 is opposite. So I4 minus I1 times 1 ohm. And for this one, it's only one current, but the current is not passive sign. So it's minus I1 times 2 equal to 0.
So if we're saying like the voltage rise equals voltage drop, even though that's a voltage rise, we're considering it negative because of that I1 going against passive. I'm sorry if I.
No. No. See, rise or drop has nothing to do with Ohm's law. Rise or drop is all based on polarity. I think you're mixing up two. So you don't even look at rise, passive sign, non-passive sign. Just look at the rise or drop in order to find the location of its voltage rise, because your movement, it's minus to plus, minus to plus, minus to plus, minus to plus. So they all go to one side, added on one side. Then you put 4, then you use Ohm's law individually. So Ohm's law individually, the current follows plus minus the other one. This one, it's a voltage rise, but the current, it's part of the voltage rise. But then you write Ohm's law, the current goes non-passive. So it's going to be still on one side. Notice I didn't change the sign. This is Ohm's law. The side is polarity. Then it's 2 times minus I1.
Oh, okay. I see. You kept it. You all in one side. You kept the value until you saw that it was
Yes. That's the best way to do KVL. Do not combine two thoughts at the same time. You get confused. Like if you think about voltage rise, voltage drop, passive sign, non-passive sign, then you get confused. First, make decision in terms of rise, fall, location, and then when you use Ohm's law, individually check the current, direction of the current.
Thank you.
Okay. Somebody mentioned about 10 problem. This problem was equivalent to 10 problem. If you repeat this problem a few times and you're comfortable, then you shouldn't have a problem with any more KVL, KCL, nodal or mesh. Okay, have a good day.
Professor, is the tutoring at 3 o'clock now?
Yes, tutoring is at 3 o'clock today, starting today. Yeah, thank you.
Thank you, Professor.
Thank you.